Regression analysis was employed to predict backorder aging from 11,000 national item identification numbers. These are called NINs, and they are unique identifiers that are used by the DLA. To give some face validity, we use some descriptive statistics and mean comparisons in order to determine if a more advanced statistical process would be appropriate, such as Bayes or even regression. We looked at regression analysis, and it indicated that there was a relationship between the administrative lead time and the production lead time, and between the backorder. So in order to further enrich our study, we decided to do a Bayes network analysis on the data. As an introduction and background, we should know that the Defense Logistics Agency and the military services employ a multi-echelon supply system to provide items of supply to the operational community. In other words, they supply everything from guns to butter. When this supply system is unable to satisfy demand, this is called a backorder, and this is identified as extending customer wait time for that particular item. So looking at things in terms of the Bayes from a conditional probabilities, as we had stated earlier, for CIIC, AMC, AMSC, and AAC, and the birth to last ship date, the probability of the birth to last ship date of being less than 90 days ranges from a low chance of 62% for these NINs that we've identified in the arms, competitive, limited, not stock categories to a high chance of 74.5% that the NIN will not be on backorder if it is pilferable, direct, procurable, and stocked. So now we've done this, and we can mix and match these components as we want to. What we've done later in the paper is to take a look at the posterior probabilities and to come up with those empirical results in order to give us a better understanding of whether something is on backorder or not. As we stated earlier, when it comes to the regression results here, the N over for the model is significant overall at a p-value of less than or equal to 0.000, and this supports our hypothesis that these three possibilities of relationship between the ALT, the PLT, and the AAC codes with a birth to last ship date would be significant. There is also support for the hypothesis that suggests that there's a correlation between the unit price and the birth to last ship date with a p-value of less than 0.005. There was no relationship found between the quantity that was ordered and the birth to last ship date. And again, the slope of the curve is positive for PLT and for ALT and the unit price, and so that as we increase any one of these variables will lead to an increase in the birth to last ship date and vice versa. Again, if something is in stock, then it should have a decreased birth to last ship date, and if it is not in stock, then it probably will lead to an increased birth to last ship date. Now, of course, there are limitations to any study, and one limitation here was the sample size. Even though we had 11,000 real-world backorders, and it seems like a fairly large sample, it only represents a subset of all the possible combinations of known variables that can be observed in the real world and studied via our Bayes technique. So increasing the sample size would lead to a more realistic project and have fewer missing values. And as more projects become available, we'll be able to obtain more data and to predict the birth to last ship date variable. And we also in this paper looked at the fuzzy logic component. So we mapped out the administrative lead time, and we also had a fuzzy component for the production lead time. We came up with the rules. We generated 9 rules that would be used to determine what would be on backorder and what would not be on backorder. And we ended up with a funnel diagram that demonstrated the relationship between the ALT, the PLT, and the birth to last ship date. So again, if we decrease a PLT and decrease the ALT, the birth to last ship date should decrease as well. Even the Bayes showed this, the regression showed this, and now the fuzzy logic can be used to prove this point as well.